Joining today's webinar on video storage solutions for mobile surveillance. My name is Tsuen. I'll be your moderator for today's webinar. We're really excited to have this use case webinar with our customer at the City of Montebello. But before I introduce our speakers, I wanted to go over some webinar logistics. We want this webinar to be interactive, so please ask questions at any time using the questions pane on your screen. I'll try to get to them real time, but we also dedicated time after the speakers present to go over any Q&A. There are handouts you can also download. We have the Cloudian Hyperstore software datasheet, along with the Lenovo DX8200C datasheet for the appliance used in the solution. Also, we have the City of Montebello case study that goes into detail on why the Cloudian Lenovo joint solution was selected for this interesting use case. As a reminder, this webinar is recorded and will be available on demand. For our viewers who are watching this on demand and have questions, please tweet your questions to Cloudian Storage or hit our website and chat live with one of our data experts. So let's get started. I'd like to welcome David Tsuen. He's our IT manager at the City of Montebello.
Via an Ethernet cable and then extract the video that way. So the average time to extract is 1 hour video to view. It takes 1 hour to download, which is very inefficient of a way of extracting video. And once it's extracted, the quality of the video is very, very low. If we try to zoom in, it gets very, very pixelated, right? So that's the challenge of pretty much analog, any analog cameras. And then there's all features that were requested from our investigator. The problem they were having was that they didn't get the fast forwarding and the rewind capability, at least not efficiently. And then there's no way to do PTZ, which is called pan tilt zoom. So what you get is what you see. There's no way to say, all right, I want to see this area, this location, zoom it in, and get the details that he needed, right? And the entire system was based on a traditional storage and on a traditional retrieving system, just copying video files through your standard SMB protocol. And on the right side, you'll see that there's a transition from the old analog cameras, that's what they look like, and to a better analog camera. Still have its own challenges, right? So we know that we needed something better. Okay. Because in the mobile environment, you got to understand that bus is always in constant movement. So you don't have a fixed camera looking at a fixed viewpoint, right? It's always moving. The subject matter, which is the human, is always moving, and the bus is always moving. So that was a really, really hard challenge. And then environment is very harsh too. So if you think about the bus, it goes through bumps, goes through vibrations. So whatever that's put into the bus, it gets a lot of beating. And the communication is limited, right? So the bus is moving all the time. So prior to 4G, LTE, getting communication, video communication through 2G, 3G, which is impossible. And then limited spacing on installing equipment too. So each of our buses have a small cabinet where we put in our radio equipment, camera system, and other various announcement systems for the bus. So it's very, very limited and very tight. And our biggest issue, however, is the inconsistent power. So you think of the bus starting and turning it off constantly, on and off constantly. That can kill pretty much any device. Think of your computer. If you unplug it, plug it back in, how does that react, right? Same way. And then also we have power surges that can knock off our equipment too. So power is a big challenge for us. And then there's a complex surveillance logistics. So offload the video, like I said before, it's done all manually. And playback, it's a little bit difficult because you rely on just time and date and time, just look for the video. We've got incidents where the investigator would say, we need video of this incident, find out that was this incident was happening with a stolen laptop, and watch the entire video for that day, which is really, really impossible to sit there and watch. Our old system didn't really have any centralized storage solution, right? So there's really no way to transfer. If you look at the image here, there's no way to transfer from the bus back to the data center. So the only way The only time we transfer video is when there's a reported incident, then we go out there and extract the video out. So there's a lot of videos that, yeah, go ahead.
So David, this is John. Now, one quick question I was kind of wondering about on that, you're retrieving the video from the bus. How in the old system, how were you handling data retention?
So we would extract videos from an incident and then pretty much store that on a regular file share server, right? But the problem is that we're only extracting incident video that was reported. So what's happening is that if there's incidents that was not reported, the video could have gotten deleted. So a month, 2 months later, somebody would file a complaint, say, hey, you know what, this is an incident. And we would say, well, there's no video. It was never reported to us. And all of a sudden now it comes up. So in that case, when anything that's reported, we have to investigate. Any investigation, whether it's true or false, it's involved dollars and time, right? So that was not an efficient way of doing this thing. We need to keep videos as much as we can, because no resident, no rider is going to tell the driver, you know what, you better record a video because I'm going to sue you. It doesn't happen that way in the real world, right? So that was the biggest challenge.
So you can really only retain data when you knew you had an incident that was involved and that data was specifically held for that incident. Otherwise, you didn't have that evidence.
That's correct. It's lost. It rewrites, our old system would rewrite the videos.
Okay.
Right. So we know that we needed a different type of solution. We know that we need something that's very unique, that's not out there in the market, right? Why? Because there's a shift from protecting assets to protecting mobile assets, right? So what's happening in the news right now all involves vehicles, bus, trucks, whatever, right? So we need to rethink of how do we protect those assets. And we were looking at a lot of different systems out there. I mean, believe me, we spent a long time looking, and we are still looking for any system that would be better than what we're trying to build, and we would stop it, right? So, but the reality is that there's very few options for bus security cameras. They're expensive, both hardware and software. It's too big and bulky, and it's excessive installation time. So what that means is the installation time also includes maintenance times too. So when we put something in there, it's never a one-time shot. It always requires maintenance. So when that maintenance comes, how easy it is to maintain the system, right? And also a lot of it is that the system out there are all proprietary. So their system doesn't talk to anybody else, and anyone else cannot tap into their system. So we didn't want that, right? We didn't want that. There's also too many incidents and not enough security personnel. This is what we're facing right now. We only have one person doing the investigation for the entire bus line, right? So we know that we need something more intelligent, intelligent security system that can monitor, analyze, assess, react, and respond to situation as quickly as possible. Because in a situation, you want the officers to respond right there as fast as it can. Otherwise, it escalates to something more serious, stabbing or death. And that has happened in our bus industry. So we wanted to develop a solution for the mobile environment that has an open architecture and open standard. So what that means is that our system that we're developing can talk to any other systems out there via APIs. And the other systems who decide that, hey, you know what, we want your information, they can actually tap into our system and get that information. So this is the component of the system that we're trying to build, right? So it involves 5 different components. The first is connectivity. You've got 3G, 4G, LTE that's provided by the cradle point if you look at the diagram. And then we have the Wi-Fi. So Wi-Fi, you have the option of going open or private. Open is basically, you know, your regular Wi-Fi 2.4 or 5G signals. Private could be 4.9 or any other channels that are private, right? And then the cameras, we actually have to think long or hard on picking the right cameras. The camera we wanted has to be all IP, all digital based, right? and then it has to have some sort of analytics built into the camera. And also it has to have sensors such as temperature, impacts, vibrations, and also one key factor is the I/O box that allows camera to extend beyond itself. What I mean by that is an I/O box will connect to an open and closed circuit board, right, such as a light. So I can send a command to the camera to tell it to turn off the light or turn on the light or whatever that we decide to tap into. So we needed that. And then the mobile NAS, we need to have something that can record on the bus itself. So the camera, imagine the camera recording to the local storage on the bus. And the reason why is in some cases there's no signal, like a dead spot under a bridge or surrounded by a building. We need to have constant recording. So we've actually experimented with different off-the-shelf recording systems such as Synology and QNAP, which both uses rsync, and to me, it's an archaic way of transferring files that was not very efficient at all. So we decided that we have to build something that is more efficient. If you think about it, if you think about how does Amazon do it, how does Google do it, transferring millions and millions of files simultaneously without any hiccups. So S3 was the protocol that they used. So we know that we needed to redesign, rebuild the blocks from ground up using the S3 protocol to transfer files, transfer videos. And then we actually had to figure out the file structure. So in order to transfer videos successfully, there's two things you've got to look at: connection and a file structure. If you don't have the right file structure, no matter how fast your connectivity is, you'll still have that bottleneck. Case example, the QNAP stores the video files 3 times as large as the rsync that we built. So you imagine transferring files at 3 times versus the S3 protocol. So that makes a difference, right?
Can
So,
you elaborate a little bit on what about the S3 protocol does make a difference?
Yeah, so the S3 protocol, what it does is it allows us to transfer multi-part files, right? Simultaneously, independently. The old rsync protocol, for example, you've got to wait for one stream to finish, then it continues another one. But with an S3, it doesn't do that. It transfers simultaneously at once, independently, with thousands and hundreds of objects read and write simultaneously to the server. That was critical because we have about 72 buses that will be having this type of storage that's syncing back to the server.
How much data is generated on a bus per day, approximately?
It depends. If we're using the old QNAP still, it's about 29 gigs. The newer one was actually 1/3 the size of it. So, and you multiply that by, yeah, that's a lot of data. You multiply it by 72 buses. That's a lot.
Right.
That's a lot of data.
So with the S3, you're able to take large files and break them down into smaller pieces that you can then upload individually. So if an upload gets interrupted, you don't have to restart the whole thing. You just restart that small piece.
Right, exactly. We've hit a wall on the rsync protocol. It doesn't do that. So that's why we needed to change the way we transfer files. And who better to follow than the Amazon, right, way of transferring files? They do that all the time. And S3 was the solution.
Yep.
Right. So these are the core component, hardware component. So let's talk about the software. I'm going to skip down to video management system, right? So we decided that we're not building a video management system software. Forget about that. Why we built when someone else already has that, right? We needed to build something that is more data-centric to handle thousands and millions of unstructured data, such as videos and other information. Like I said before, Amazon and Google does it. Why can't we use this principle to apply to the security industry, right? And the next thing we said, we want the unified management platform to be accessible at any location on any devices without installing an app or an API, right? We need it to be a web application without specific installation on any device. Then we also need the application to be web-centric with a bunch of APIs. And then lastly, we need a storage that is built for the web with a lot of APIs. And that was one of the key reasons why we selected Cloudian for this. Why? Well, we know offhand that the video storage is gonna grow endlessly, because our target is to store all the videos for 1 year. You can imagine that how many videos we'll be storing, right? So we need something that can scale and maintain performance at the same time. And then we also need something that will allow us fast filtering and search capability. We need a multi-tenancy. We need a simple way to extract the video and data. And we need a way to archive the video without needing specific software. So, and the only solution that can allow us to do that is an object storage system based on Cloudian. So I think I've gone through this pretty well already. So the Cloudian, again, object-based storage, metadata capable, scalable, S3 transport, and HTTP API rich, and cost-effective. So cost-effective to me is actually interesting because you can actually upfront cost or maintenance cost. With the Cloudian solution, we actually reduced our maintenance cost and also programming cost, because everything is stored in a flat file. It makes it a lot easier for our programs to program rather than programming for, if you think about it right now, all your files, you actually have to think about the size, the structure, and all the other things involved. With the object storage, everything's flat. All the information is with each of those files, which makes it a lot easier for our programs, developers to use. And then our developers actually TSS, which they introduced the Iris technology, the Unified Management Platform. It's based on Internet of Things. It's made for Internet of Things. It's all web-based, viewing, video streaming, playback, and on-demand video, all web-based. So it's accessible on your phone, on your tablet, or on a computer. And the HTTP API rich allows us to actually tap into other systems. That's crucial because we needed that to tap into the Cloudian, which is rich in HTTP APIs. And then we needed the technology to be based on the HTTP REST capable, which allows us to transfer videos, files, and offload much more efficiently and automatic. So this is kind of a diagram. Yeah, go ahead.
I have a couple questions that are coming in about your implementation. Someone here wants to know, what are the specifications of the camera that you're using, if you're able to disclose that?
We can. Funny thing is that's going to be on a different case study, and it is a long list, right? So for me to describe all the other, all the components of the camera system, it's going to take a lot of the time here. So they can reach out to, I don't know, they can reach out to somebody, and then somebody can forward that information to me, and I'll send them the criteria.
Just big picture. I mean, what kind of resolution are they, and what kind of frame rate you're running?
The camera allows us to do two things. So the viewing, we can set at a different frame rate, and the recording, we can set at a different frame rate. So right now, the recording onto the bus is full frame, 16 frames per second, full HD. And we can actually adjust that from what, 1020 by 900 up and down.
Okay, great. That's a good start. Okay, another question, Tim?
Nope, that's it for now.
Okay.
Okay,
great.
So this is a diagram of the topology of the entire system, right? So you've got the Iris Manager, which is actually the UPM that the dispatcher or security officer will be accessing. You can access, they show a desk here, but you can access that anywhere. You don't have to be tied to a desk. And then the UMP is actually stored on a server, on a Lenovo server that doesn't very little requirement in terms of resources. And then we actually have the cloud server storage. All communicate through the internet, to the bus, to the LTE Wi-Fi, the switch, and the camera and the iris sync. That's all that's required there. As a matter of fact, each of the camera actually has an SD card on there as a secondary backup storage. So should the iris sync totally fail, you actually still have videos on each of these cameras as a redundancy. And then we actually have something called Iris Live Mobile. So our thought was that we actually have supervised vehicles, and we actually have ridership vehicles, share riders vehicles that we want to track. So instead of installing cameras with this complex system onto a vehicle, a regular vehicle, we decided to create a mobile app for it on your phone that would tie back into our unified management platform.
You can really see on your diagram, David, why S3 was so important to this, right? Because you're really relying on the internet for every phase of the communication. So having that protocol that works reliably over the internet through wireless and landlines was really critical to the success of this project, wasn't it?
Exactly, because your storage is web ready, internet ready. The iris sync is web and internet ready. So that was the core reason why we chose clouding, was that we want our system to be web-based, accessible anywhere, all over the country. I mean, that's the whole idea of the system, is you can be anywhere. Because believe it or not, our bus runs on the weekends, day and night, pretty much on very strange time. When there's an accident, our investigator can access from his home or wherever he's at through the internet and get the video feed that he needs, do the reports that he needs right away. So that's very crucial. We're not tied to a desk anymore. So this is a screenshot of what the unified management platform looks like. So this is our dashboard with vehicle statistics. So at any time, you can see the temperature in the vehicle, the speed, the altitude, and the location right there and then. And this is our tracking, the real-time GPS tracking. So these are different buses. There's actually one in Palm Springs. So it's a real-time tracking. So if there's an incident, we can view the video live. It's a live feed. Well, this is a screenshot, but you can view the video live feed. And it also gives you the ability to record right on the fly. Now that's interesting, because when we record it, we want to type information such as location, date, and time for easier search. And that's why we needed the Cloudian's metadata to do that for us.
Does this help you pull together the information to view incident from different angles, from different cameras, for example?
Yes. So these are different cameras. So we just select whatever camera we want to view, and you can see it right. So the investigation part, which I don't have a screenshot of, just because the file was getting too long. That allows us to actually search for videos and incidents. So we wanted to be able to search videos much easier. So as an example, if we want to search videos on a location, so we can say, all right, give me all the videos that is at this geographic location. So that's actually important for us. We actually get requests from the police and other agencies to say, hey, there was an incident here. Did your bus capture any incidents? So now we can say, oh, it's right here. Let's look at it, without having to search for date and time and sit there and look for it. It's just not practical. So the solution gives us the ability to transfer the files in route or back at our station, right? So with our on-demand video recording, we can get the video right there instantaneously. Or if there's no incident, the bus comes back up, back to the depot, and then offload the video via Wi-Fi, without having to go there, plug in with a laptop and get the video out. And then we actually have simultaneous recording of all cameras in real time with metadata tagging. So So it's going to give us rich metadata search to allow us to find videos quickly with geographic location, vehicle IDs. And we're actually going to be adding driver ID and also other parameters such as bus diagnostics to the entire system. So you imagine you can see the video and you can see the health of your bus at the same time. What happened to the accident? Then you can say, oh, the diagnostic said the brake wasn't working or there's low brake fluid. So you can correlate and investigate much, much quicker. And then it's cost effective, right? Cost effective, and then we're getting a centralized video storage that can scale into petabytes in a single environment. Or we can actually have what we call a multi-site environment where we could be the main storage, and all the other agencies can just extract the data that they need into their location. Cost effective, as I said, very cost effective, because this system is a hybrid system. We can actually say store the videos that we need locally, videos that we don't need after a year to another site. And it's full S3 API compatible. That was the key.
So it sounds like this system is really going to save you, a lot of money, both in terms of the video operations itself, but also in terms of how you're handling surveillance overall. It's going to save money, in many different ways, don't you think?
Yes, absolutely. So when we say cost, I mean it's not just the dollar value; it's time as well too. You got to take into factors such as time, staff. Those are all cost saving, and maintenance as well too. That has to be taken into consideration, and also redundancy too. So we know that we need to keep this video. Imagine your storage going down, you lost the video, and it's a critical lawsuit. Whatever cost that was associated with buying the system is out the door. None of our lawsuit is under $1 million.
Well, that puts it in perspective.
Right. And you got to think about it. This is public transportation, right? So one vehicle has how many? 25 passengers. So you're talking about 25 passengers suing you at once. It's different from a car. It's different from a car. People don't realize that it's the liability on a bus is very, very huge. Well, I know that because we're going through one case like that.
So if you have all the facts on a single incident that helps save the city on a lawsuit, that pays for the system many times over, right there.
Many times over. One case is like it's millions and millions of dollars. So and if it's found that we're liable, then that's it. Those other dollars flying out. It's like trying to save a penny, but step over a penny, and try save a penny, but you're wasting money on a dollar. So you got to put that into perspective.
Terrific. All right, that's awesome, David.
All right, so I'm going to give the controls over to you, John.
I'll advance to the next one. Okay, so this system that David went through is a object storage-based system with storage provided by the Lenovo appliance. It's called the DX8200C, and it's powered by Cloudian software. So we at Cloudian make the underlying software behind this appliance, and it provides that S3 compatible object storage that David's been talking about here. And what's exciting about S3 is it is the storage protocol that was born on the internet. So in David's example, internet connectivity played a huge role in his ability to execute all of his objectives. The multi-part upload, the ability to work reliably over both wireless and wired internet connections. S3 plays a huge role in that because it was designed to work over the internet. It was designed to be cloud-based storage. So that's what we and Lenovo are providing here. And this solution, is perfect for the hybrid cloud, because not only can you download information specifically into this device, but you also have the ability to tier information off into the cloud as well. So you can use both on-premise storage and cloud storage within a single environment if you choose. The Cloudian solution with Lenovo is designed to start small and scale seamlessly. I think this is one thing that's really critical about David's example. He's collecting a lot of data every day, and his objective is to retain that data over time so that they can protect themselves in the future. Well, to do that, they have to grow the environment as the data accumulates, and that's one thing the Cloudian makes very easy. Growth is simply accomplished by adding on nodes. There's no disruption at all involved in adding on new capacity. So Cloudian is a Silicon Valley-based company founded in 2001, and actually the roots came from the mobile messaging space. So Cloudian was actually behind the technology that first enabled pictures to move over wireless links, so over cell phones. And that was a technology that's actually still applied in our today's product, which is object storage. So the same databases and management we used for that high-volume messaging is used in today's platform. Cloudian is venture-backed with about $79 million in venture funding, with some really prominent investors and partners, including Lenovo. The solution is simplicity itself. Applications move data over S3 into the Cloudian Lenovo environment, and that can be anywhere from a small number of terabytes up to hundreds of petabytes. And that data can all be held on-premise for as long as is needed, and can also be tiered off into the cloud. So that's why we say it's a hybrid storage environment. Both that on-premise environment and that cloud appear as a single management environment. So when you look at the Cloudian device, you see everything, what's held on-prem and what's in the cloud. So essentially, you have limitless capacity within a single namespace. And that's why we say that Cloudian is exactly the same thing as cloud storage in your data center, because everything you love about the cloud, all of the scalability and the ease of management and the low cost, it's really included in the Cloudian environment as well. The only difference is that Cloudian resides in your data center, so the data is locally accessible to your applications. And the advantages that gives you is performance, because it's locally accessible, data locality, you know exactly where your data is, and then you have complete control over the management of it. There's no cost to access it. The feature set of Cloudian is unmatched in the industry. We have a fully native Amazon S3 API, which means that we were designed from the start on the S3 API. So that was the original premise of the company, was to deliver object storage via S3. There's a lot of really advanced features which are included in the S3 API, and we support them all, from multitenancy, which means you can operate with multiple different operating environments within the same storage space, QoS, so you can have multiple users all sharing a resource with no noisy neighbor problem. And then billing, you can see where, account for what each user is doing. There's numerous policy-based tools, including data protection, tiering, and then a single file system for files and objects. So we have the ability to store files as well.
Oh, John, can I interrupt you really quickly on the,
yes.
The discussion on multi-tenancy? That was actually one of our key features that we're looking for too, because we're actually sharing our technology with other agencies as well too. So we actually have agencies such as UC Davis, Sunline, that are part of this beta testing the system here, that will be carving a section of the storage and all the storage and the features for them. So that was actually very important. So we don't want to mix and match videos, between agencies.
Yeah, that's a really good point. We see a lot of environments like this where people are scaling their storage big, and then they want to share that big pool among multiple users. So the ability to wall the users off and maintain individual environments, individual namespaces, individual security within that common environment is really important. So yes, multi-tenancy is something that factors into a lot of use cases. And in fact, this is applicable to a lot of different use cases. I've already mentioned on-premise storage. It's also applicable to multi-site storage. So you can take a single cluster and spread it across multiple data centers with all the units in the different data centers interacting within a single namespace. So in David's case, as they grow, you may see them expanding into other data centers and other locations. They can all be networked together and operating as a single cluster.
Right. Also, as a failover too. Sorry to interrupt, John. It's also as a backup too. So we can take our most critical videos and say, all right, we want to have redundancy. If ours fail, we still want to have that multi-million-dollar case video somewhere else.
Exactly. So redundancy is built into the environment, right? So when you set up a node, set up a cluster, the nodes are redundant, right? There's no single point of failure. And depending on how you configure it, you can have multiple levels of data redundancy as well. So it's all configurable at the at the data level, as opposed to having to configure things at the system level. So you can choose individual types of data and make them as robust as you want them. This is very applicable to storage MSPs, people that are looking to set up S3 as a service, because it's got the multi-tenancy and the configurable redundancy. So for storage MSPs, it provides the exact same feature set they need to provide services and also billing. And then, as I mentioned earlier, hybrid, the ability to not only store data locally, but also tier it off to the cloud. So you essentially have limitless capacity in an on-prem storage environment. The solution is proven at over 100 customer sites in a variety of different use cases. So obviously, City of Montebello, a great state and local government use case. We've also got use cases in technology, use cases in service providers, use cases in retail, use cases in medical. This is something that fits into a wide variety of application environments. Most commonly in backup and data protection is one of the most common use cases we see. People were using this in conjunction with backup software, such as Veritas or Commvault or Veeam or Rubrik. They use the Cloudian solution as a backup target. That's a very common use case. Media and entertainment is another common use case, using this as an active archive for media that's in production. And obviously, what David is doing is essentially it's another example of a media type of use case, a subset. It's obviously surveillance, but yeah, storing of images is a really critical part of this whole environment. This customer that's mentioned on this slide, NTT, is a photo sharing service, and they've got over 2 million users on a single Cloudian environment in a photo sharing environment. So image storage is obviously a very spot-on use case for an object storage system. So to summarize, the Cloudian Lenovo solution combines a number of really useful assets. Foremost among them is the Amazon S3 API interoperability. This was the API designed to move data over the internet, and that has a lot of implications for how you can manage storage in your environment. All of a sudden, it becomes easy to move data long distances. There's no special tools required and no special third-party software. You just do it as part of the system, and that makes things like video transfers possible that previously would have been really challenging. The fact that it's hybrid cloud means that it works not only as an on-prem storage solution, but with the cloud as well. And it's available in different kinds of deployment options. So David deployed his using the Lenovo appliance. It's also available in software. It's also available in metered by use configurations. So to sum up, this is an S3-based on-premise storage device with terrific scalability, S3 interoperability, data protection, and an unbeatable cost point, all in a single solution. So with that, thank you very much for your attendance. And Tam, do we have any questions we want to address at the end here?
We do. We have a couple questions. The first one's for you, David, and I think you did answer this already, but are your cameras on the bus recording locally to an SD card?
Yes, as for failover, we're recording to the SD card on each camera and also onto the iris sync. So we have dual redundancy as well.
Got it. Excellent. Okay, so next question, this one's for you, John. In terms of data protection, does Cloudian Hyperstore partner with any backup vendors such as Veritas NetBackup, Commvault, and Veeam?
Right. So part of the beauty of Cloudian's S3 interoperability is it is the most interoperable S3 on the market. So it works flawlessly with a number of software solutions out there support S3. And Tam, the ones you mentioned in the data protection space are great examples. Commvault NetBackup and Backup Exec both support S3. This was put in place so they can back up to the cloud. It works just as effectively to back up on-prem to the Cloudian solution. So that gives you instantaneous, RPO, RTO, because you have the data right there immediately available at a very high data transfer rate. So you can make your backup window and meet your recovery objectives as well. Same thing applies to Rubrik, Commvault, and then with Veeam, they do file-based backup. We have connectors for that as well. So yes, you absolutely have interoperability with a number of data protection solutions that people are already using, and they can use it tomorrow with S3 storage on-prem.
Got it. And you mentioned the S3 API compatibility. The next question is for you, John. Is Cloudian Hyperstore the only vendor out there that's fully S3 compatible?
So there's a number of different vendors that support the S3 API, but Cloudian is the only one that was built exclusively on the S3 API from the start. So we say it's native because the other folks were built on different APIs and then use translation to go up to the S3 API. We have S3 API built right into the core of our software, which ensures both the interoperability, the robustness, and the reliability of the solution.
Excellent. So that's it for questions for today. Thank you so much for your time today, David and John. Again, please download the handouts if you haven't already. There are 3 handouts there. So you have the Cloudian Hyperstore software data sheet as well as the Lenovo DX8200C data sheet and the City of Montebello case study with all the details. Again, this webinar is recorded and will be on demand. Thank you, everyone, for joining today, and have an excellent rest of your day.
Thank you.
Great. Thank you.